Okay, so these are some more examples from section 8.3 on hypothesis testing. First, I want to remind you that the hypothesis testing is a 4-step process. Okay, you have an example of the hypothesis testing with that 4-step process written at the top. I want to make sure that you have that handy until you get used to what that process is. Okay, so here's the problem. Now, really, this is how most of your problems are going to look, just a paragraph. And so you have to pull out all the important information and create the test on your own. Curling. A research center claims that 16% of U.S. adults say that curling is the winter Olympic sport they would like to try the most. In a random sample of 300 U.S. adults, 20% say that curling is the winter Olympic sport they would like to try the most. At alpha equals 0.05, is there enough evidence to reject the researcher's claim? Okay, claim. That's the first thing you want to look for, is whatever that claim is. And a research center claims that 16%. Okay, I like to write the claim down first. Claim. Proportion, that's what we're dealing with, equals 0.16. Okay, it's equal because it doesn't say less than, greater than, more than, anything like that. So it's exactly 16%. Once you have your claim written, you should then be able to write the null hypothesis, because it's going to match, because the equal sign is in the claim, and the equal sign has to be in the null. The alternative will be a not equal sign. So there's what our test is about. We have a claim, we have a null, we have an alternative. We can also see at this time, because of that not equal sign, that we have a two-tailed test. If you want, you can go ahead and start step 2 by drawing in the curve that you're going to use. So we have that normal curve, 0 in the middle. We know we're going to have two tails. I'm going to go ahead and shade them, and I will label those two tails in a minute. All right, now I'm going to go back, and I'm going to write in all that important information that comes out of the problem. Our claim, or our original P, and we're calling it P sub 0, is the 0.16. So we also need a Q sub 0. So that will be 1 minus the 0.16, or 0.84. Then we need a P hat. Now, in this particular case, the P hat was given as the 20%. So that's 0.2, or 0.20 if you want, for P hat. Now, they didn't give us an x over n to calculate. They went ahead and calculated the P hat for us and gave it to us. We do need the n, which is the number in the sample, and that's 300. The significance level they're asking us to work with is alpha equals 0.05. Okay, that alpha equals 0.05 is going to lead us to that critical value z that we need. Remember, this is a critical value. Okay, going to the table. Because we have a two-tailed test and an alpha of 0.05, we're going to look at two tails over to 0.5. And then because it is a z, all the way to the bottom, and we have a 1.96. That 1.96 goes on both sides. One is positive, the other is negative. Negative to the left of 0, positive to the right of 0. So this is plus and minus 1.96 are the critical values. Okay, so this gives us, what's it called? The reject regions, yes. And in this case, there's two of them. All right, we've actually completed step 1 and step 2 now. Step 3 is the calculation. We are using a test statistic, z, and z will equal I'll go ahead and write the formula here. P hat minus the P sub 0 over the square root of P sub 0 times Q sub 0 over N. So filling in all of those important information. P hat from our list is 0.2 minus 0.16. Again, I suggest you put it in parentheses for the calculator use. Square root of 0.16 times 0.84 divided by 300. Okay, on the calculator, parentheses, 0.2 minus 0.16, close parentheses, divided, open the square root, 0.16 times 0.84 divided by 300. And that gives us a test statistic of 1.89. And it's positive. Well, 1.89 is not out here beyond 1.96. It's falling somewhere right in here. 1.89 is not in the reject region. Not in the reject region. Now we have enough information to make a conclusion. The first sentence in the conclusion needs to be about that rejection or not. And we are not going to reject the null hypothesis here. We could say we're failing to reject the null hypothesis. Okay, so we're going to write first, since 1.89 is not in the reject region, the null hypothesis is not rejected. Once you know about the null, then you want to look back up at your setup, and the null is matching the claim. Since we can't reject the null, we can't reject the claim. So the claim we're going to support. And now I'm going to go back and read about what that claim says so I can rewrite it in my conclusion. It says a research center claims that 16% of adults say that curling is the winter Olympic sport they would like to try the most. I'm just going to take that sentence and rewrite it as a statement supporting that claim. So, we rejected the null hypothesis. Therefore, the research center's claim that 16% of U.S. adults say that curling is the winter Olympic sport they would like to try the most, comma, is supported. And we're done. So we're supporting the original claim. So this is what a problem looks like in total. In total. And it's a lot. Okay, so you have to give yourself room on the paper when you're writing these problems. Don't try to make it too tiny. Especially if it's on a test or a quiz that I have to read all of this. Okay, I have to see it all and I have to read it all. So you want to make sure that your handwriting is even better than mine, so that I can read yours. Okay, another one. Sometimes your problems are going to look like, well, not a blank piece of paper. Really? Just a disappeared on me. Like this. Okay, so a little graph and a little bit of information. A little animal in the graph. Should draw your attention, right? Okay, a recent survey claimed that at least 70% of U.S. adults believe that cloning animals is morally wrong. To test this claim, you conduct a random telephone survey of 300 U.S. adults. In the survey, you find that 189 adults believe that cloning animals is morally wrong. And here's a little picture of the 189 and the 111 out of the 300 that they called. Cloning animals morally wrong. Cloning animals is morally acceptable. Then it says that the 0.05 alpha, is there enough evidence to reject the claim? Okay, so let's talk about that claim. A research survey claimed that at least 70%. At least 70%. What's the inequality that goes with at least? Very good. So the claim is that P is greater than or equal to 70%. Okay, now the equal to sign is there in the claim. Therefore, it's going to be in the null hypothesis. That's how you decide. And then the alternative hypothesis will have the opposite, which in this case will be a less than sign without the equal to. The less than sign tells us that we have a one tail to the left, curve. We'll find that Z test statistic in a moment. The other important numbers that we need from the claim, we have the P sub 0 equaling 0.7. Therefore, the Q sub 0 equals 0.3. P hat. Now, this is where we need to go X over N to find our P hat. X was the number of successes, and this is about the morally wrong. So it's 189 over the total was 300. So P hat is going to, I'm going to do that division real quick. And that's going to be 0.63 for the P hat. Our alpha is given to us as 0.05. And from there, we can now find the critical value, the Z critical value. Okay, one tail, 0.5. One tail, 0.5. All the way to the bottom, 1.645. It is negative because it's on the left. So our reject region starts at negative 1.645. Now we're ready for our Z test statistic. P hat minus P sub 0 over square root 0.7 times 0.3 divided by 300. Negative 2.65. Okay. That is located pretty far out in the reject region, so it's out here. So now we know that we are rejecting the null hypothesis. Since the test statistic falls in the reject region. The null hypothesis is rejected. Okay, looking back at the null, it says at least 70, and that matches the claim, so we have to reject the claim as well. So looking back at what the claim actually is in words, a recent survey claimed that at least 70% of U.S. adults believe that cloning animals is morally wrong. Well, we're going to reject that. So we can even say the claim that at least 70% of U.S. adults believe that cloning animals is morally wrong is rejected. Not too bad. Any questions?